On July 1, 2025, astronomers detected a visitor racing through our solar system at 150,000 km peach, 3I Atlas, only the third interstellar object ever found. But when NASA analyzed its data, world-renowned physicist Michio Kaku saw signatures that challenge everything we thought we knew about cosmic wanderers. The object fragmented, left strange emission trails, and its chemical fingerprint refused to match any known natural process. If Kaku is right, this could be our first real hint that we are not alone. But does the 3I Atlas anomaly reveal intelligence, or is the universe simply stranger than we ever imagined? The answer begins with a signal in the quiet of the Chilean night, midwinter on the Atacama Plateau. If you find this story fascinating, make sure to subscribe for more deep dives into discoveries that could reshape our understanding of the cosmos. The sky above Chile is jet black, scattered with stars so dense they blur together at the horizon. In a concrete dome outside La Serena, the Atlas Survey Telescope sweeps its final field of the night. It's July 1, 2025, just after 4 a.m. local time, when a faint streak interrupts the routine. The signal blinks once, then again, each return confirming it isn't a ghost or glitch. On duty, 2 night shift astronomers, faces lit by the glow of monitors, watch as the object's coordinates lock in. The system flags an anomaly, apparent motion too fast, trajectory too steep for any known comet or asteroid. Within minutes, the raw data pings across the network to Hawaii, then onto the Minor Planet Center in Massachusetts. The initial readout puts the object's path at a sharp angle, coming from the deep southern sky, speed already off the charts. The telescope's CCDs, cooled to near absolute zero, capture a handful of frames, just enough to trace a thin arc across the starfield. By sunrise, the Atlas team in Chile has logged a discovery unlike any in their career. The observatory's logbook records the moment, July 1, 2025, 8:13 UTC, Atlas, Chile. An object later catalogued as 3I Atlas has entered the system, traveling at nearly 150,000 km. The world's astronomical community wakes to an alert. A visitor from beyond the sun's domain has been caught in the act. Astrometry comes first, pinpointing the object's position against the fixed stars frame by frame. As Earth spins beneath the dome, each new data point sharpens the arc, shrinking uncertainties and revealing a path that slices across the solar system at an impossible slant. Within hours, observatories in Hawaii, South Africa, and Australia join the chase. Their telescopes, tuned to the coordinates from Chile, catch the same streak, confirming it's not a local wanderer, but a visitor on a one-way journey. The numbers start to settle. 3I Atlas is moving at nearly 150,000 mph, about 67 km relative to the Sun. That's faster than any asteroid ever catalogued, nearly triple the velocity of typical long-period comets. For comparison, Oumuamua, the first interstellar object, clocked in at just 26 km/s. This new arrival is in a different league entirely. As the orbit solutions converge, the eccentricity climbs past 6, a value that leaves no doubt. This is a hyperbolic trajectory, not a closed loop. The object is inbound from the high southern sky on a path retrograde to the planets, almost as if it's threading the solar system backwards. The inclination, calculated at nearly 175 degrees, places it just 5 degrees shy of a perfect polar entry. Its closest approach to Earth will be about 1.8 astronomical units, never coming nearer than the orbit of Mars. Statistical models run by the Minor Planet Center show less than a 1 in 7,000 chance of such a high-speed retrograde visitor passing this close by random chance. The orbit is rare, the speed is extreme, and the data are airtight. For the astronomers, the implications are immediate. This isn't just another comet. It's a messenger from the deep between the stars, and the clock is ticking to capture every possible measurement before it vanishes forever. Within minutes of the final orbit solution, the Minor Planet Center issues a circular. 3I Atlas is classified as the third interstellar object ever observed. The alert fans out through the International Astronomical Union's network, pinging inboxes from Tokyo to Tucson. Automated systems at professional observatories trigger follow-up scans, while amateur astronomers comb the sky for a new streak among the background stars. The data is blunt. Closest approach will be 1.8 astronomical units, safely beyond Mars. No risk to Earth, but the rarity is impossible to ignore. Out of thousands of near-Earth objects tracked each year, only 2 confirmed interstellar visitors have ever crossed the system before. Now a third, moving faster and on a stranger path, demands attention. Coordination teams at NASA, ESA, and the Rubin Observatory assemble in virtual meetings, passing the numbers and distributing observation windows. The goal isn't just to watch a spectacle, but to capture every possible photon before the object disappears into deep space. Each telescope logs its schedule, each data packet routed to shared archives for rapid analysis. The global astronomy community shifts into high gear. Protocols honed on previous alerts now guide a response that stretches across continents and time zones. For a brief window, the world's eyes are aligned, focused on a single messenger from the stars. The object's safe miss brings relief, but its origin and trajectory keep the searchlights burning. The handoff from detection to interpretation has begun, and the question now is not just where 3i Atlas is going, but what, if anything, it might reveal. Michio Kaku stands at the crossroads of science and public imagination. Born in San Jose, California in 1947, he grew up building atom smashers in his parents' garage, driven by the dream of understanding the universe's deepest secrets. His path led through Harvard, then the Berkeley Radiation Lab, and onto a career as one of the world's leading theoretical physicists. Kaku's research spans string theory, quantum mechanics, and the hunt for a unified field theory, a quest to tie together all the forces of nature, from gravity to electromagnetism. But it's not just his academic credentials that set him apart. For decades, Kaku has served as a bridge between the frontier of physics and the living rooms of millions. His books like Hyperspace, Physics of the Impossible, and The Future of Humanity have landed on bestseller lists worldwide, turning complex science into stories that anyone can follow. He's a regular voice on national radio, the face of countless science documentaries, and a frequent guest on television networks from CBS to the BBC. When NASA or CERN breaks big news, it's often Kaku who fields the first questions, translating technical jargon into plain English with a trademark sense of wonder. Kaku's reputation rests not only on his command of equations, but on his willingness to ask the questions others shy away from. He's argued that the search for extraterrestrial intelligence is not just idle speculation, but a scientific imperative. He's called out the gaps in our understanding of cosmic phenomena, suggesting that what looks like noise in the data might be the faint signature of something or someone beyond our current grasp. This willingness to follow the evidence wherever it leads has made Kaku both a respected academic and a lightning rod for debate. Whether he's discussing the feasibility of warp drives or the odds of finding life beyond Earth, his voice carries weight. For many, Kaku is the scientist who makes the impossible seem possible, and who reminds us that the universe is still full of surprises. In the story of 3i Atlas, he becomes our guide, not just to the facts, but to the possibilities that lie just beyond them. Kaku's approach to cosmic mysteries is grounded in a simple rule: questions before conclusions. For every headline about an alien artifact or a signal from the stars, there's a checklist, one that separates real discovery from wishful thinking. The checklist starts with skepticism. Not every oddball in the data is a message. Sometimes it's a glitch in the detector, a cosmic ray striking a sensor, or a cold pixel on a camera chip. Astronomers have learned this lesson the hard way. The so-called WOW signal in 1977, a burst of radio noise from deep space, sparked decades of debate, but no repeat event ever followed. The Mars face from Viking orbiter photos turned out to be a trick of shadow and sunlight, not a monument built by lost engineers. Comet tails have masqueraded as UFOs since the dawn of telescopes. Each time, the scientific method demands a pause. Is this pattern in the data, or just in our minds? Kaku doesn't dismiss anomalies out of hand, but he insists on a chain of evidence. First, rule out the mundane. Instrument errors, software bugs, and natural phenomena get crossed off the list one by one. Only when the usual suspects are exhausted does the door open to more exotic ideas. In the case of 3i Atlas, the object's speed, trajectory, and chemical makeup raise eyebrows, but so far nothing crosses the threshold from strange to unexplainable. The data are real. The interpretation is cautious. This is the heart of scientific skepticism. It's not about saying no to wonder. It's about making sure wonder doesn't run ahead of the facts. Kaku's method is a model for anyone fascinated by the unknown. He asks, what would it take to prove this is more than nature at work? What evidence would convince even the harshest critic? These are the questions that keep science honest and that keep the search for cosmic company on solid ground. In a universe this vast, the line between noise and signal is razor thin. The only way forward is to question everything, even our own excitement.